Welcome back. So we are continuing our introduction to integration today. We'll be talking about definite integrations, that's area between two different x values, how to integrate trigonometric functions, and then how to find the area between two different curves, which will allow us to find the area of any shape we want. So starting out with undoing all of our trigonometric rules. So if this is our original function, f of x, then our derivative would be the other side. So if I derive sine, I get cosine. If I derive cosine, I get negative sine. If I derive tangent, I get secant squared. If I'm integrating, I would work backwards. So that means the integral of cosine discard, try that again. Okay, so that means the integral of cosine would be sine of x, again plus c, because we don't know if this had been sine x plus 4, when you derive it, that plus 4 will go away. If you integrate negative sine, you'll get cosine. If you integrate secant squared, you'll get tangent. Cosecant squared, you'll get cotangent. Secant x, tangent x, you'll get secant x. Negative cosecant x, cotangent x, you'll get cosecant x. So this is just working backwards. Again, integration is answering the question, what did I derive in order to get this value? So in order to get cosine, I would have had to derive sine of x plus some constant. Okay, pretty straightforward. Any questions on this one? Okay. A little bit more interesting, if I wanted to find the area of a curve, last time we said the area underneath the curve would be what happens when we integrate. So if we integrate this one, I'll divide by dx, add 1 to the power, so this 2 will become 3, and then divide by the new power. So if I divide by 3, that's 1/4 times 1/3 is 1/12. So that gives me this x cubed plus x cubed over 12 plus c. And then I wanted to figure out how much this area would have changed between x equals 0 and x equals 5. So underneath the curve from 0 to 5, what we can do is I can plug in 5 to see how much our area changed from 0 to 5, and then subtract what happens when I plug in 0. How much area do we already have at 0? If I do, this will be 5 cubed over 12 plus c minus 0 cubed over 12 plus c. So I just plugged in this upper bound, and then subtract what happened when I plugged in my lower bound. So it's always upper minus lower. Okay. Upper minus lower. 0 cubed is 0. C minus c is also 0, so these will cancel. And I'm left with 125, that's 5 times 5 times 5 over 12 is my total area inside this green space. Okay, if I wanted to cut off at any point that was not 0, so let's say I want the area between x equals 2 and x equals 5. What I can do is I can get all of this red space area between 0 and 2 and subtract that red space area from the total area for 0 to 5, which we got last time. So if I take the total area that we had last time at x equals 5 and subtract the area from 0 to 2, I should have what we want, the area between 2 and 5. Here's what it looks like. So I'm going to integrate 1/4 x squared again. The first step's still the same. Divide by dx, add 1 to the power, so this will become 3 instead of 2. And then divide by the new power. If I divide this by 3, 1/4 times 1/3 is 1/12. Okay, again, I'm going to plug in my upper bound and my lower bound. What that's really doing is this is getting all of the area from 0 to 5, and then I'm subtracting all the area from 0 to 2. So that'll leave me with the area between 2 and 5. So once again, this is upper minus lower. If we do that, so 5 cubed is 125, 2 cubed is 8. So this would be 125 over 12 minus 8 over 12. Oops. Mistype on my part. There we go. 125 over 12 minus 8 over 12 is 117 over 12. And then my c's will also cancel. Any questions on what happened here? Okay, general idea again. Our area from 0 to 5 minus our area from 0 to 2 should be our area from 2 to 5. So if I have all of this red space area, and then I get rid of the white space area, then I'll be left with just the green area. Okay, we can also take this idea and use it to find the area between two curves. So here I have f of x. If we integrate, we'll get the area underneath it. So that's all this area here in yellow. And g of x, another function here in blue. If we integrate this function in blue, I'll get the area underneath the function in blue, which would be this orange area. So this orange area is the area under gx. So if I want to get the area between them, this space in here, I can take the total area underneath our larger function, f of x, and subtract the orange space, the area under the smaller function, to get the area between them. So I could also say the area between two curves is the area under the top curve minus the area under the bottom curve. If you wanted to write that out mathematically, that would be the integral from your start point to end point of your top function minus the integral from your start point to end point of your bottom function. Or in this case, the integral of f minus g from a to b. Because my bounds are the same, and integration is just repeated addition, I'm adding again and again and again all of the areas of these infinitely small boxes, which have a base of dx and a height of f of x. Or for the smaller function, have a base of dx and a height of g of x. Because it's just repeated addition, I'm adding all of those infinitely small areas together forever until I get the total area underneath the curve. As long as my bounds are the same from a to b, I can combine those two integrals. So that gives me one integral then of my top function minus my bottom function from a to b. Any questions on what we did here? Okay then, so let's try one example. I'm going to flash one first. So I've got the area between the two curves provided. This is a little bit blurry, but I've got our functions down here. So I've got f of x, which is negative x squared plus 8x minus 10. So that's this parabola opening down. And g of x, x squared over 2 minus x minus 5 over 2, which is this parabola opening up. So that means the area between them in this blue space here that we want would be the integral of f of x minus g of x. Okay, so the first thing I need to do is figure out where the start point and the end point is, because they didn't give it to us this time. So to figure out where the start point is, so that's my point here at A, and my end point at B. I'm going to set the two equations equal to each other, and we'll solve for x. Okay, so here's start point at A and end point at B. Okay, so I'll set the two equations equal to each other, which I've done here. If I do, I can multiply everything by 2 to get rid of all of my fractions. So this will be negative 2x squared plus 16x minus 20. And then x squared minus 2x minus 5. I'm going to move all of my x squareds to one side. So if I move this 2x squared over to the other side, 2x squared plus x squared is 3x squared. The negative 2x minus the 16x is negative 18x, and the negative 5 plus 20 is plus 15. Okay, that gives me an equation that we can factor. I might, if it's easier for you guys, you could have taken this and divided by 3. If you did, you would end up with something like this. 0 is equal to x squared minus 6x plus 5, and that might be easier to see. So that'll factor into x minus 5, x minus 1, which gives us x equals 1 or 5. Okay, so now we know our bounds. A was 1, B was 5. So I want to integrate fx minus gx from 1 to 5. Okay, so here's f of x. F of x is this. So f of x is this. And g of x, which is here. F of x minus g of x. Okay, I'll need to distribute that negative. So if I do this, will be negative x squared minus x squared over 2 is negative 3 halves x squared. 8x minus negative x is 8x plus x is 9x. Negative 10 minus negative 5 over 2, that's negative 20 over 2 plus 5 over 2, since I'm subtracting a negative, is negative 15 over 2. Okay, then we can integrate. So for each one of these terms, I'm going to add 1 to the power and divide by the new power. And then we'll plug in our upper bound minus lower bound. Any questions on what we're doing? Okay, I'm going to try another one from scratch. Okay, let's do this one. That's cool. Okay, I'm randomly generating on these on the fly, so I want to be able to talk through them. Let's go ahead and throw this to the back. Okay. So if I want to start this, the first thing I want to do is integrate our function. So I'm going to integrate our function from negative 1 to 2. In terms of x. If I do, what's going to happen for my first term?
So we integrate the function first and 2 of an x, right?
We're going to integrate the function first, yes. So x cubed, if I integrate it, will become what?
X power of 4 over 4.
Okay, x to the 4th over 4, minus 3x squared over 2, and 5x. Okay, then I'm gonna give myself a little bit of space and just drop a line straight down and write my bounds because I need to plug in my upper bound and lower bound. So I can script that like this. My lower bound is -1 and my upper bound is 2. Okay, so I would read this as so for my first step, I want to integrate x cubed minus 3x minus 5 in terms of x from x equals -1 to x equals 2. Okay, on bottom, I could say that integral is equal to x to the 4th over 4 minus 3x squared over 2 minus 5x from -1 to 2. And then for my next line, I'm going to plug in my upper bound and lower bound. So that'll look like this. I'm going to take this equation and we're going to replace all of our x values with our upper bound. So I'm going to change all of these x's and replace them with 2. Okay, so that's my upper bound, and I'm going to subtract my lower bound, which is the same idea. I'm going to take all of these x's and replace them with -1. Okay. So then we just need to solve. So I've got 2 to the 4th power is the same thing as 4 times 2 squared is 4. Minus one of these 2's will cancel, so that's left with 6 minus 10. Okay, I'm going to distribute this negative. So this will become 1/4, and then if I distribute the negative, it will be -1/4 minus 1/4. A negative and a negative is a positive, so this will be positive 3 over 2. Okay, I've got a negative times another negative when I distribute is still negative, so this is -5. Okay, then we can add straight across. Okay, so I've got 4 minus 16 is -12, minus the 5 is -17 for all of my constants that aren't in fractions. And I'll get a common denominator for this other side, so 3/2 is the same thing as 6/4. So 6/4 minus 1/4 is 5/4 plus 5/4. Okay, then 17 times 4 is 68. So this is -68/4 plus 5/4 should be equal to -63/4. Okay, so my area is -63/4. Again, our negative just means direction. So this is telling us our area is in general below 0. Any questions on what we did?
Yeah.
Okay. You can get an estimate maybe. So 63/4 is 15 3/4. So we'll see if we can prove it graphically really quick. So I should have 15 3/4 values here if we did this correctly. So hopefully we'll get close. I've got 9 units here that are completely filled in. I'm going to say this one and this one are roughly 10, 11, 12, 13, 14, 15, and a little bit. Okay, so definite integration, just integrate and then plug in your upper bound minus lower bound. And we'll do one more area between two curves. This time we'll use a trig function. That looks cool. Okay, so we are finding the area between these curves again, this time from pi fourths to 3 pi fourths. So this will be the integral from, be a little bit more careful this time, pi fourths to 3 pi fourths of my top function minus the bottom function. So this top function is my 2 cosecant squared. Minus my bottom function, so that's minus negative 2 sine x. It's the same thing as plus 2 sine x in terms of x. Okay, so then I'm going to integrate. The function I would need to derive in order to get cosecant squared. If I derive cotangent, I get negative cosecant squared. So in order to get a positive cosecant squared, I would have to derive negative cotangent. Okay, and then I've got that 2 in front, so I'm going to put a 2 in front here. If I derive negative 2 cotangent x, I would get negative 2 times negative cosecant squared, which is positive 2 cosecant squared. Okay, the same thing over here for sine. In order to get a positive sine, when I derive cosine, I get negative sine. So if I derive negative 2 cosine, I would get negative 2 times negative sine is positive 2 sine. Okay. And then upper bound of pi fourths and 3 pi fourths. Okay, so then I just need to plug in. My upper bound of 3 pi fourths. And lower bound of pi fourths. All right. And we'll substitute from the unit circle. So from the unit circle, we're looking at 2 points. So this is pi fourths, which is the point where x and y's are equal. They're both root 2 over 2. And we're looking at 3 pi fourths. My magnitudes are still equal, but my x value is negative. Okay, so cotangent would be x over y. So my first value would be negative 2 times my x over y at 3 pi fourths. So that would be this x negative root 2 over 2 divided by my y positive root 2 over 2. Which would give me this. Negative 1. Minus 2 times my cosine is my x value, so that's negative root 2 over 2. Okay, So that's all my upper bound. I'm going to do my sines as a separate step this time. Okay, minus my -2 times the cotangent at pi fourths. So again, that's x divided by y is √2/2 divided by √2/2 is 1. Minus 2 times my cosine at pi fourths, which is √2/2, my x value. Okay. Let's move this out of the way for a minute. And we can simplify, and we should be good. Okay, so I've got 2 plus √2 minus -2 minus √2. 2 minus -2 is 4. √2 minus -√2 is 2√2. Okay, any questions on what we did here? Mhm. That was my mistake. So I copied the last question originally as pi, when it should have been -pi6 and pi6. So that's kind of why I hesitated when we got 0, because you can see on the graph it's not supposed to be 0. That was because our bounds were wrong. So did another problems, just so I could go through without any mistakes. Okay, so I've got a series of homework questions that are exactly like what we did in the examples. I'm also going to post these examples now that I've fixed 13 with the right bounds and you've got 14 worked all the way through. So I'll give you 2 examples for area between curves and 1 example for definite integration that you can use as a guide to help you out if you get stuck. So let me save this really quick and post that to the WeChat, and then you guys will be good to go. For our next class on Friday, I am considering trying to stream on both Skype and Zoom simultaneously, so if you guys have bad connections on one or the other, you guys can just pick whatever program you want to use. We'll see how well that works. Okay, thank you guys very much. I will see you on Friday. Goodbye.